There is a point beyond which the sun no longer rules. A distant boundary where the solar wind slows, weakens, and finally gives way to something older, colder, and far more unfamiliar. A region where the influence of our star fades into the vastness between stars. For most of human history, this boundary was theoretical, a line drawn by equations, not observation, a concept debated in journals, not witnessed by instruments. Then, something crossed it. Not a spacecraft designed for interstellar travel, not a machine built with modern technology, but a probe launched in the 1970s, carrying computers weaker than a calculator, drifting silently through space for decades. That probe was Voyager. When the Voyager missions were launched, their purpose was limited. They were built to explore the outer planets: Jupiter, Saturn, Uranus, Neptune. No one expected them to last more than a few years. No one imagined they would become humanity's first messengers to interstellar space. Yet they endured. As decades passed, Voyager continued traveling outward, farther from the sun than any human-made object before it. Long after its planetary mission ended, it entered a new phase, one that no mission planners had originally prepared for: the slow journey toward the edge of the solar system. At such distances, space itself begins to change. Near Earth, space feels empty, but it is not. It is filled with charged particles streaming outward from the sun, the solar wind. This invisible flow shapes a vast bubble around our star known as the heliosphere. Inside it, the sun's magnetic field dominates. Outside it, something else takes over. Voyager was heading toward that boundary. For years, scientists monitored its instruments, watching for subtle changes: the decrease in solar particles, the increase in cosmic radiation from beyond the solar system, shifts in magnetic fields, variations in plasma density. Nothing dramatic happened all at once. Instead, the transition was slow, confusing, and deeply unsettling. Voyager began detecting fluctuations that did not fit predictions. Solar particles dropped unexpectedly, then returned. Magnetic fields strengthened, then weakened. Plasma readings behaved erratically. The edge of the solar system was not a clean boundary. It was turbulent. At certain distances, Voyager detected sudden spikes in high-energy cosmic rays, particles moving at near light speed, originating from distant supernova and violent cosmic events. These particles had been partially shielded by the heliosphere. Now that shield was thinning. The data suggested Voyager was approaching the heliopause, the region where the outward pressure of the solar wind balances against the pressure of interstellar space. But the instruments disagreed. Some readings indicated it had crossed the boundary. Others suggested it was still inside. The magnetic field direction remained similar to the sun's field when it should have shifted. For months, then years, scientists debated what Voyager was actually detecting. Had it crossed the boundary, or was the boundary far stranger than expected? Then came a signal that changed everything. Voyager recorded a sudden and sustained increase in plasma density, the density of charged particles surrounding the spacecraft. Inside the heliosphere, plasma is sparse. Outside, in interstellar space, it is denser. The readings matched interstellar conditions. Voyager had left the solar system, but confirmation did not bring clarity. Instead, it raised new questions. The magnetic field outside the heliosphere was aligned almost exactly with the sun's magnetic field. This contradicted existing models. Scientists expected a sharp directional change, a clear marker of transition. It did not happen. Instead, the sun's influence seemed to stretch farther than predicted, blending with interstellar space in a complex interaction zone. The boundary was not a wall, it was a region filled with turbulence, compression, and unexpected structure. Voyager was not simply crossing into emptiness, it was entering another environment entirely. As it continued outward, the spacecraft detected waves traveling through interstellar plasma. These waves were triggered by shock events far away, solar eruptions and distant stellar activity, propagating across light years of space. The idea that a solar event could still be felt at the edge of interstellar space was unexpected. It suggested connectivity on a scale far larger than previously assumed. The sun's influence, while weakened, was not gone. Voyager was listening to the echoes of a star long behind it. And then came something even more unsettling. At extreme distances, Voyager's instruments began registering anomalies that could not be easily categorized. Fluctuations in particle energy, variations in cosmic ray intensity that did not match known cycles, magnetic turbulence without clear sources. These were not malfunctions. The instruments were behaving consistently. Space itself was behaving differently. The interstellar medium, once imagined as quiet and uniform, revealed itself to be dynamic, uneven, and structured. Regions of higher density, pockets of turbulence, magnetic irregularities. The space between stars was not empty. It was active. Voyager had become humanity's only direct observer of this region, a single point of data drifting through an ocean no one had ever sampled before. There was no map, no reference frame, no comparison, only one spacecraft. And that spacecraft was still moving. As Voyager traveled farther, its signal grew weaker. Commands took more than a day to reach it. Responses took another day to return. Every bit of data became precious. Engineers had to decide which instruments to turn off to conserve power. Each shutdown was permanent. Each decision narrowed the window of observation. Eventually, Voyager would go silent. But before that happened, it would continue to send back information from a place no human had ever touched, a place beyond the sun, a place where our solar system ends and something else begins. And what it detected there would quietly reshape our understanding of where we exist in the universe. For decades, scientists believed the edge of the solar system could be defined cleanly, a boundary where the sun's influence ends and interstellar space begins. A transition marked by a sudden change in particles, magnetic fields, and radiation. Voyager revealed something very different. The region surrounding our solar system is not enclosed by a solid barrier. It is wrapped in a vast, distorted bubble formed by the solar wind, a continuous stream of charged particles flowing outward from the sun in all directions. This bubble stretches far beyond the orbit of Pluto, shaping the environment through which every planet moves. This structure is known as the heliosphere. Inside it, the sun dominates. Its magnetic field guides charged particles. Its energy shields the planets from much of the harmful cosmic radiation. The solar system, it seemed, was not enclosed by a rigid shell. It was embedded. This realization reshaped how scientists understood stellar systems. If our sun's influence blends gradually with the galaxy, then other stars likely form similar overlapping structures. The space between stars becomes a complex web of interacting magnetic bubbles rather than empty void. Voyager's data suggested that the galaxy is not neatly partitioned. It is layered, dynamic, and deeply interconnected. As the spacecraft moved farther into interstellar space, the protective shielding of the heliosphere diminished. Cosmic radiation increased steadily. These particles are among the most energetic in the universe, capable of penetrating spacecraft hulls and damaging electronics. Voyager measured this radiation directly. The readings confirmed that the heliosphere plays a critical role in protecting life-bearing planets. Without it, Earth would be exposed to far greater levels of cosmic radiation with profound implications for biology and climate. In this sense, Voyager did more than mark the edge of the solar system. It revealed how fragile our position truly is. The sun is not just a source of light and warmth, it is a guardian, creating a habitable pocket within a hostile galaxy. Beyond that pocket, conditions change. Interstellar space is colder, radiation is harsher, magnetic environments are unfamiliar. The relative safety humanity has always known is not universal. Voyager is now traveling through this environment alone. Its power source, a slowly decaying nuclear generator, limits its lifespan. One by one, instruments are being turned off to conserve energy. Each shutdown silences a sense, sight, touch, hearing, until only the most essential remain. Yet even as systems fail, Voyager continues to transmit. It sends back whispers from beyond the sun's reach, data that no other spacecraft can provide. There is no redundancy, no second observer, only one fragile machine carrying humanity's curiosity into the dark. And what it continues to detect suggests that interstellar space is not empty, not calm, and not uniform. It is shaped by forces on scales we are only beginning to understand. Voyager crossed a boundary humanity once believed was simple. Instead, it found complexity, and that complexity raises deeper questions. If the edge of our solar system is not what we imagined, then what else have we misunderstood about our place in the universe? Far beyond the last planet, beyond the thinning influence of the Sun, Voyager continues to send data from a place no human instrument was ever meant to reach. There are no landmarks there, no familiar reference points, only particles, fields, and faint signals drifting through the dark. Out there, the spacecraft is not observing objects, it is observing conditions. And those conditions are not what scientists expected. As Voyager moved deeper into interstellar space, its instruments began detecting patterns that challenged long-standing assumptions about the environment between stars. The interstellar medium had often been described as thin, calm, and relatively uniform, a sparse fog of particles spread across vast distances. Voyager revealed something else. Particle detectors showed that cosmic radiation did not arrive evenly. Instead, it fluctuated. Intensities rose and fell in irregular cycles. Some changes correlated loosely with solar activity far behind the spacecraft. Others did not. This suggested that interstellar space is structured, not smooth. There are regions of compression, turbulence, and magnetic complexity, invisible boundaries that cannot be seen, only inferred through changes in energy and motion. Voyager passed through these regions one by one, each subtly different from the last. The magnetic field data was particularly unsettling. Rather than stabilizing after leaving the heliosphere, magnetic field strength continued to fluctuate. Directional changes occurred gradually, then unexpectedly reversed. The field behaved less like a static background and more like a living system in motion. This contradicted simplified models that treated interstellar space as passive. Instead, it appeared responsive. At certain points, Voyager recorded sudden increases in magnetic intensity, as if passing through compressed regions. Invisible ridges in space formed by interactions between stellar winds from different stars. These regions may be shaped by ancient supernova explosions or by the collective influence of nearby stars moving through the galaxy. In this environment, space itself seems sculpted by history. Voyager also detected plasma waves unlike those measured closer to the Sun. These waves moved through interstellar plasma slowly, carrying information about density and energy over enormous distances. Some were traced back to solar eruptions that occurred years earlier, still propagating outward like echoes. Others had no clear origin. They appeared spontaneously, without an obvious triggering event. Their frequencies did not match known solar patterns. Their presence hinted at dynamic processes occurring far beyond the heliosphere, processes that are not yet fully understood. The idea that events could be unfolding in interstellar space without any direct connection to the Sun forced scientists to reconsider the role of the galaxy itself. The Milky Way is not just a backdrop. It is active. Stars move through it. Gas clouds collide. Magnetic fields twist and reconnect. Shock waves from ancient explosions continue to ripple through space long after their sources have faded. Voyager was detecting the after effects of cosmic history. Another surprise came from particle energy distributions. Voyager's instruments showed that some cosmic rays were being modulated even outside the heliosphere. Their energies changed in ways that suggested interactions with structures in interstellar space. This raised a critical question. If cosmic radiation is being altered before reaching the solar system, then our understanding of radiation exposure, both for spacecraft and for life, may be incomplete. The heliosphere was once thought to be the primary shield. Voyager's data suggested it was part of a larger, layered system of protection and interaction. Space, it seemed, was not empty. It was negotiated. As the spacecraft traveled farther, its signal grew weaker. Engineers on Earth had to amplify receiving systems, combine antennas across continents, and wait longer between communications. Commands sent to Voyager took more than a day to arrive. Responses took another day to return. There was no real-time control. Voyager was operating largely on its own, following instructions sent months in advance. Any unexpected behavior had to be interpreted after the fact. This delay added another layer of uncertainty. When Voyager recorded an anomaly, there was no way to immediately adjust instruments or change course. Data arrived already in the past. Interpretation lagged behind reality. And yet, the spacecraft continued to function. Its systems, designed for a few years of operation, endured for decades in an environment never anticipated by their creators. Every transmission felt increasingly fragile, a whisper across billions of kilometers. Among the most haunting aspects of Voyager's journey is what it carries with it. Attached to the spacecraft is a record, a curated message from humanity, intended not for scientists, but for whoever or whatever might encounter it in the distant future. Sounds, images, greetings in dozens of languages, a snapshot of Earth as it once was. At the time of launch, this was seen as symbolic. Now, as Voyager drifts through interstellar space, the symbol feels more literal. The spacecraft has outlived its mission, its designers, and in some cases, the world it left behind. Nations have changed, technology has advanced, entire generations have passed. Voyager remains. It carries no propulsion system to turn back, no ability to stop. It will continue moving through the galaxy long after its power fades, long after its signal disappears. Eventually, it will fall silent, but its presence will remain. What Voyager detects now is subtle, incremental, difficult to interpret, yet each bit of data reshapes our understanding of where the solar system ends and where the galaxy begins. The boundary is not a line, it is a region of interaction, and Voyager is moving through it alone. The spacecraft has become something more than a scientific instrument. It is a reference point, a marker placed at the farthest edge of human reach. Everything beyond it is unknown. Everything behind it is home. And between those two lies a question that grows more profound with distance. If interstellar space is this active, this structured, this dynamic, then how different is it from the environments around other stars? And what does that mean for the universe as a whole? By the time Voyager moved fully beyond the Sun's protective influence, it had stopped being a planetary mission, or even a solar mission. It had become something else entirely, a probe of the galaxy. For generations, the Milky Way was imagined as a backdrop, a vast, distant structure composed of stars, dust, and empty space in between. The region between stars was treated as passive, a quiet void separating luminous objects. Voyager's data quietly dismantled that picture. Interstellar space is not empty, it is not calm, and it is not uniform. As the spacecraft continued outward, the measurements it returned painted a picture of a medium shaped by motion, pressure, and history. Magnetic fields twisted through space like invisible rivers. Particle densities varied across regions, forming boundaries without walls. Voyager detected that the interstellar medium is structured in layers, some compressed, some rarefied, influenced by forces far beyond the Sun. These layers likely formed from interactions between stellar winds, ancient supernova shockwaves, and the slow drift of gas clouds through the galaxy. Envision a quiet wanderer, floating solo in the immense void, farther than any man-made item has ever reached. Billions of kilometers away from home, beyond the reach of our sun's light, a small spacecraft continues to send faint signals back to Earth. These whispers hold tales of bizarre realms, tumultuous tempests, extraterrestrial forces, and the enigmatic boundary where our solar system concludes and the galaxy commences. Inaugurated over 40 years ago, the Voyager missions were not intended to endure for such an extended period. Despite all challenges, these twin pioneers have surpassed their creators, surpassed their fates, and revealed mysteries that transformed our comprehension of the universe. At the boundary of interstellar space, Voyager discovered phenomena previously deemed impossible: unseen barriers of hydrogen, the eerie resonance of the galaxy itself, and hints that confront all our understanding of where space genuinely starts. This is more than merely the tale of two devices, it's the tale of mankind's most significant jump into the unfamiliar and the astonishing revelations that awaited us in the endless darkness. This is the unspoken account of Voyager's astonishing findings at the border of the solar system. It was the year 1977. Humankind was still discovering how to aspire towards the stars. Only 8 years before, we had set foot on the moon, but beyond that stretched a wide, unexplored frontier. NASA envisioned a goal to dispatch a messenger further than ever achieved, a spacecraft capable of reaching the distant planets, Jupiter, Saturn, Uranus, Neptune. and possibly, just possibly, going past them. Yet, there was a single issue. These worlds were unimaginably distant from each other. Then arrived an extraordinary chance that happens once every 176 years. The planets were ideally positioned for one spacecraft to slingshot from one to another, utilizing gravity as an interstellar route. Thus, two robotic trailblazers emerged, Voyager 1 and Voyager 2, twin adventurers designed to transport humanity's inquisitiveness into the vast unknown. Billions of kilometers distant, Voyager glides on, quiet, relentless, everlasting, not merely a traveler of worlds, but a representative among the cosmos. Shocking discoveries beyond the edge. As Voyager 1 passed the heliopause, humanity did so alongside it. For the first time, a device constructed by humans ventured into the expanse between the stars, an area devoid of sunlight, where neither planet nor magnetic field could offer immunity. What it discovered there shocked even the most cautious researchers. 1. The sound of the galaxy. At first, the data seemed almost silent, background noise, faint static from a dying probe. But when scientists at NASA's Jet Propulsion Laboratory translated the plasma wave readings into sound, something eerie emerged, a low, ghostly hum, rising and falling like distant music. They realized Voyager was detecting vibrations in interstellar plasma, the charged gas that fills the void between stars. Each wave was caused by shock fronts from ancient solar eruptions colliding with the surrounding medium. To human ears, it sounded like the universe itself was breathing. This wasn't an ordinary sound, of course, there's no air out there. But these oscillations revealed density, temperature, and rhythm in what had once been thought to be empty space. The galaxy, Voyager showed, wasn't silent at all. It sang. When researchers sped up the audio, the tones formed a cosmic symphony, slow pulses and trembling frequencies that told a story 18 billion kilometers away. Each note represented the heartbeat of a living, shifting interstellar ocean. For the first time, we could hear beyond the solar system. 2. The magnetic field shock. If the heliopause were simply a wall where the sun's wind stops, scientists expected the magnetic field outside to change direction completely. But Voyager's magnetometer told a different story. The field beyond the boundary was stronger than expected, and oddly aligned, almost parallel to the one inside the heliosphere. It was as if the two regions were not separated by a clean break, but stitched together by invisible threads. This discovery baffled researchers. Some proposed that the sun's magnetic field might be entangled with the galaxy's own magnetic web, twisting and reconnecting in ways never before imagined. Some proposed that Voyager had not entered completely open space, but rather a transitional zone, a magnetic cocoon protecting the solar system like a cosmic membrane. The consequence was tremendous. Our solar system may not finish suddenly, but instead slowly merge into the interstellar medium, intertwining light and darkness in a chaotic boundary spanning tens of millions of kilometers. The data from Voyager compelled scientists to revise the boundaries of our sun's domain. We were residing in a magnetic bubble floating in a galactic ocean, and Voyager had just grazed its radiant surface.